Hey everybody, Mr. Keeney here again. We're here for our third section. I got myself confused. Third section of Unit 2 notes. It is day 2 of section 2.2. And all that means is we're going to continue talking about conditional statements that we did our last section of notes. And the overarching kind of goal here in our unit is to use deductive reasoning to form a logical argument. So again, today I kind of mentioned last time that we're going to work more towards geometric arguments and geometric ideas. Last time was just getting the structure down of what is a conditional statement. And we're going to be talking about something called a biconditional statement, where it actually goes both ways. I'm going to be talking about that here in a little bit, but let's get started with a little bit more of geometric ideas. Here's something you might be familiar with. It's called perpendicular lines. If two lines intersect to form a right angle, then they are perpendicular lines. Now, the cool thing about this definition is you can see here that I have my if, which contains my hypothesis, two lines intersect to form a right angle, and then the then, which has a conclusion. They are perpendicular lines, just like when we were talking about conditional statements. Now over here, you're going to see that this definition can also be written using the converse. Now, to remind you, converse switches the hypothesis conclusion. So we started with if P, then Q. The converse says I can actually do the other way. If any two lines are perpendicular lines, which was our original conclusion, then they intersect to form a right angle. And if you were to think about this, it is true for both, and this would be true, let me write, and this would be true. So it works for, my goodness, I cannot write right now. It works for both the original and the converse. That's what Mr. Keeney's trying to say. He just struggles with talking sometimes. So this idea of original and converse are both true. We can switch the hypothesis and conclusion and still have a true statement. That is our big deal. Why are we talking about this? We're going to have a term, a new type of statement for it. Before we move on, let's talk about this geometric idea. This geometric idea, perpendicular. You can write line L is perpendicular to line M as L is perpendicular to M. So a little notation real quick. Perpendicular is an upside down capital T. Us as mathematicians sometimes get a little lazy. We want to have symbols, kind of like an equal sign or plus or subtract or congruent. We don't want to write out the full word. So perpendicular is a really long word, so we have a symbol for it. In our picture over here, you can see that we will also put a little box to show that we have a right angle. And then down here, you can see a little statement. Line L is perpendicular to line M. I want to take you back now to a little bit of logic. When a conditional statement and its converse, so a conditional, reminder, if P then Q, and converse, if Q then P, if we were to switch it up, if they're both true, you can write it as a single statement called a biconditional statement. A biconditional statement basically takes the conditional, takes the converse, the fact that they're true, and we're going to write it in a different form. And we're going to use this phrase, if and only if. And again, mathematicians, we are very lazy when it comes to writing things out. So if and only if, we can actually do IFF. That is not one of my misspellings. That's actually, I did it correct. IFF, you can read as if and only if. And so we're going to do this perpendicular definition that we talked about above, where we have the conditional and the converse. And we're going to write it as a biconditional. So actually, I'm going to need to see it real quick. It says for our hypothesis, two lines intersect to form a right angle. Conclusion, they are perpendicular lines. Now, here is how we are going to write it. Before we write it out in words, let me show you the notation. Instead of going P to Q, instead of going Q to P, we're going to show that this one goes both ways. It is a biconditional. That prefix bi, meaning two, like bicycle, it has two wheels. I'm trying to think another one right now. Anyway, bi means two, so it goes two ways. It can go P to Q. It can go Q to P. You can see it's going to have both those arrows. We're going to connect the hypothesis and conclusion with if and only if. So first we write a hypothesis, which I got to look again. Two lines intersect to form a right angle. So hypothesis, two lines intersect to form, oh my goodness, a right angle. All right, so there is our hypothesis, and then we're going to connect it with this if and only if. I'm going to underline it just so you can see there's a connecting. And they're ready for a conclusion, which is they are perpendicular lines. They are perpendicular, such a long word, perpendicular lines. Okay, so reading it all out. Two lines intersect to form a right angle if and only if they are perpendicular lines. So we can read that as the way we're reading right now. If the lines form a right angle, then they're perpendicular. It also can read backwards to say if lines are perpendicular, then they will intersect to form a right angle. So both ways, biconditional, two ways, two arrows, if P then Q, if Q then P, and we're going to say P if and only if Q. All right, one more, and then we're going to be done. Short notes today. Write the statement below as a biconditional. Again, both ways. It says if a student is a boy, he will be in group A. If a student is in group A, the student must be a boy. So we have these two kind of statements here. So one, and I'm actually going to erase this to make this a little bit clearer for us. I'm going to use this first one. A student is a boy. There's kind of like our original hypothesis, and the conclusion, he will be in the, and I didn't put then, that's kind of my bad. Then he will be in group A, and you can see here I switched it so the converse is kind of being written. So we got PQ, we got QP. They're telling us they want us to write it as P if and only if Q. So if we wanted to do that, we're going to say a student is a boy if and only if he will be in group A. There we go. So I'm connecting the P and Q using if and only if. We're going to use more example one where it's definitions. That probably seems a little bit more geometric. It makes a little bit more sense in our heads. But there it is. There's these notes: biconditional, true conditional, true converse. It goes both directions. When we meet together, whether that's online, in person, we will go over this a little bit more. So thank you for watching. I'll see you guys later.